This is TrainMe, the ultimate render machine. At the heart of Talon, amid the noisy startup ecosystem, there is one particular startup that will disrupt the industry of remote computing. Whether you're crafting blockbuster films, epic games, or mind-blowing AI, TrainMe's cloud infrastructure platform will deliver lightning-fast rendering and unbeatable computing power, all with a super-friendly interface. No tech wizardry required at all. Already we have film studios, game developers, and AI geniuses who are riding the TrainMe wave, turning big ideas into reality faster than ever. Get ready, because with TrainMe, the future of remote computing is fun, fast, and right at your fingertips.
We are live.
Hello, welcome to this webinar where we talk about setting up the Deadline cloud version and looking at the pros and cons of each step you need to go through. Welcome again, my name is Argo Kasper. I've been a DevOps engineer for a very long time now, and I've been focusing more into setting up visual studios and visual effects pipelines for the last couple of years. So the common problem, what you've heard and thought about probably with setting up clouds for your render jobs is what will the cost be? So you never know actually, but during this webinar I'm going to show you the bits and pieces where you can kind of assume and make accurate estimations into your cloud budgets and cloud costs. The outline for today will be the following. So I will be talking about how to right size your instances in cloud, which types of instances to use, whether they are accelerated with a GPU or not. Then how to control the costs, which is a pretty important topic almost always with cloud. Then I'll talk about a little about scaling, whether you need more instances, you need to scale up, or whenever you don't have any activity or renders going on, then we can scale back down and have zero costs of idling on instances. And lastly, talk about storage options. I would briefly mention 3 that mostly is used, and then I'll finish off with just a small comparison and about my ideas and thoughts comparing the self-managed Deadline setup or the cloud-managed one, and also talk about the interaction or between the two, so to have a kind of a hybrid solution. And of course, if you have any questions during the webinar, we are happy to receive them, and I will answer those during the end of the webinar. All right, enough of this introductions. I will just try to get into, because I have a lot of topics to cover. So I'll start with leaving this page here, which I was preparing before, but let's go into here. So that would be the page you see when you go into AWS. You have to be logged in first, of course. For this example, I have created a testing farm. They are called farms there. And what I want to show you first is how to right size your render nodes. So in here, they are called fleets. So in Deadline, what you do here, let's go ahead and create the queue even. So it's completely fresh from the start. I'll rename it to VFX rendering queue, and that will be like our primary one if I had a studio. I will choose an existing bucket just because I wouldn't want to bother assuming the correct name. I have it already timestamped. What I would do is rename the root bucket. So during this approach, you would reuse the same bucket, so easier management, but you just specify the different root folders. So in this, I will copy the name just to be following the naming patterns, remove the spaces, and then that's done. I won't do any associations just yet because we're going to create those fleets later on. The queue budget, because we'll be focusing on the cost, so I would choose the option to, before you can even use the queue, you would need to really set the rules for your budget. So we'll get to this later on. And there is a default action, what you can do. What is most convenient and not so disruptive is that it will complete the tasks and then shut down from receiving any further jobs. When we scroll down here, for the ease of this example and in general cases, you would just create the new service role. AWS has this pre-configured, so you don't need to really dive into the specifics of it. You can just leave that as is, and everything else also you can leave as they are. These are the best practices that I've used, people and studios still use. Of course, you can configure them however you wish, but let's carry on currently. Since these resources, they take some time, up to 10-15 seconds to be created and fully usable. So what happened now is we created the VFX rendering queue. Currently, it doesn't accumulate any cost. It's just there as a configuration. And as of this state, you cannot submit jobs either. But the next step, what I wanted to show you was the associating of the fleets. And let's go ahead. First, let's go ahead and create a new fleet where we can. So you have to go under the fleets in the resources page, create. New rendering nodes. So in here, because it's a bit more technical webinar, I will go over to customer managed fleet details so that you can have more control over. Just a small note, if you choose service managed, all the instances, auto-scaling groups, you don't see them anywhere in other areas of the AWS. You will just get billed for them. So it's I don't like this option so much because I prefer to see the resources I'm using. Whenever I use something out of the norm, I can just quickly go in and delete or stop it. So that's why customer managed is the option. Fleet service role, again, like I mentioned with the creation of the queue, you can leave the default. These are the best practices used, and in general, you don't need more permissions, so to say, that come along with this role. So we click next. You have different options, 3 main operating systems choices. I will keep Linux. And CPU architecture, I will also keep the 64-bit one, not ARM. Then minimum vCPUs, I will bump up the maximum ones just because some jobs might require more, but I won't put it up too crazy because we would want to have a horizontally scalable instance fleet, but up to 16 is. So you can do pretty heavy renders with these. Minimum memory, 8 to 24. So I'm kind of aiming towards a medium range render node. And at the bottom here, it's usually hidden. But what I need, also in this webinar, I'm going to use an accelerated nodes, which means in AWS, in other terms, you can attach a graphics card. And these graphics cards are mostly, they support the RTX technology, but they are not like the commercial ones. So the models are different, like Tesla data center specific graphics card models. And these depend on the instance type you choose later on. I will maybe just bump it up to 2 maximum, and the memory I will use 12 gigabytes as max. So these are the ranges how instances will be chosen for you that are most appropriate. Let me actually go back if I... Yeah, no, it's all right. So next, we don't need, so this is an extra layer of configuration. It's if you have a really specific workflow, then it might be beneficial, like allocating specific jobs, frames, so to say, to render in specific fleets or nodes. So, but at this webinar, we won't be focusing on that. The next slide here is testing or selecting the correct queue. So with this render fleet, I will be adding, let me see why it showed this error. So it's requiring some credentials. So in this case, you can also allocate more than one queues. Let's go ahead and tackle that. Wait, wrong. So this is, it's always something that can happen. So stop scheduling local VFX queue. Okay, let's go back to here. Run as a user, not. All right. For this instance, not really sure what I missed. I might have just gone over while talking too confidently here. Some important things. Here it is. So queue configured worker agent user. I will choose a worker agent user because this is the username you would configure when creating the worker. So I will save changes here. Now we have the fleet. Let's refresh. See, the error is gone. So we can carry on with attaching the fleet with the queue. And finally, next. So in here, you can see just an overview of the settings. So we go ahead and create the fleet. This is taking some time. It finishes here roughly with 15 to 20 seconds, and after that, it needs a few more moments to be fully operable. So next, what I would do, remember I set the constraint for the budget of this queue I just created. I would actually head now to the dashboard. So if you go to dashboard in clouds, then you see the monitor. This will prompt you for a username. I have pre-configured users here. I will first log in and then quickly show you where you can manage these users. So, and also multi-factor authentication is enabled by default, which is good to have more secure access. So it is sign in. So in here you would be seeing something that is more familiar for you when you've used to looking at the deadline interface. So, and now it's a browser based, so up until this point you haven't needed to, and you don't even have to install anything on your workstation. So we go on to the recently created queue. You can see it's blocked. The reason is because we set the constraint for budgeting. We go into it and it starts to show a bit more errors. Let's see where it points out where we actually need to set that budget. And it's in the top. So it requires a budget to run the jobs. To do that, we go to the fourth element or fourth menu item on the left and click on a create budget button. So now we can just a temporary budget. You can write anything, and this resource bit here is the link kind of. So you set up a queue, set up this budget for a specific queue, and in our case it was VFX rendering. It already states that there is a default action. So if I don't do anything anymore, well, I have to set the amount. it will have one action, even though at the bottom here nothing is configured. So let's go ahead and set up this budget to be $333. And you can see there is a start and end date. So for here they have pre-configured it for 3 months, which is an average project length, maybe depends on the project still, but I would say an average. But in our case, I would say that we need the project done much faster, so I will set it to be just 1 month. Let's see what it does us for then. So from 20th to the 20th of April. And I would still want to set some limit actions just to be I don't know, more paranoid, or make sure that actually the budgets are followed so that the cost won't go totally out of the scope that we allocated to it. So what you can do here is basically you can set as many options, but you have only 2 actions. So you can either stop everything after going over a threshold, or you can just stop after the current job has finished. So I like to think that there's like a soft stop and a hard stop. So I always set both of them. So if the remaining amount is, let's say, I do usually 10% and 1%. So 333 is, so if there's 33, no, like 60, let's say 70 remaining, then it will just stop the new jobs from coming in after the currently finished job. And then the last one would be if we have less than $30 left, it will stop everything immediately, because we never know, it might be a really heavy render job and it might blow the roof off of the budget we have set. So it's like a safe side of budgeting to be set here in deadline. And this is really good. This will make it sure that you never go over. Of course, you can always modify those budgets, but it's good to have them set before. At the bottom here, you can see another budget I have created. So now you should be able to start sending, let me refresh the page because it's still showing. It's blocked. Requires an active budget. Oh, the budget date range was set to something which makes it not active. Also, it can just take time, as those things in cloud are. They are not instantaneous, but it's never more than like a minute. So you have to just come back to the different settings from time to time. In the beginning, not always. What I wanted to show you as the last thing here with the budgeting is a really nice dashboard. This is difficult to see in self-managed deadline installation. So in here you can see estimations, how you've been using it. You can right size after a certain time when you see that the estimations and elapsed times are more or less stable, that there's no huge differences anymore. And you can do all sorts of reporting from it as well. Of course, AWS has a much bigger reporting service, which this one runs from. It's called Cost Explorer or CloudWatch. So if you go into these services, you would see this as well, but in a much more configurable way. So you could do almost anything what your mind can think of with reporting or just controlling something cost-wise. So next, what I would do, just go back to so we have the new render nodes. So now I would want to show you the scalable side, auto-scaling side of the nodes that you would set for your render farm. Let's quickly just check why the status here hasn't updated yet. Active budget, but it has an active budget, so I'm a bit, maybe it's just stage nerve that I have, but cannot really see the reason why it's still saying it's unusable. So I would want to use this queue. Let's just carefully check each step. So it requires an active budget. We created the budget. We even attached it to the VFX rendering queue. Interesting. Let's go here. Test farm, VFX, new render nodes, allowed. So there are many places to look for the fault currently, but it's probably something I have missed during the flow of just demonstrating you. But let's carry on. The next topic I wanted to tell you about was the auto-scaling option and how you can properly scale up and down your instances, because again, what I've seen from really automated and service managed side of the deadline is whenever your renders end and there's nothing more coming up, the node is scheduled to shut down and be removed from your fleet only after 5 minutes. I know it's not too long of a time, but in cloud, these little 5 minutes idling times can just add up on your bill at the end of the month. So what I like to do is make it shorter, at least 2 times shorter. So let's go ahead and check the auto-scaling rules that are, for instance, for the nodes here. Worker capabilities. Okay, this requires, so now if you want to really customize your auto-scaling objects and scale the cloud resources on your fleet, you would need to go to auto-scaling. So this is part of the EC2 auto-scale. And open it up to new tab. AWS auto-scaling. Just double checking. They have changed recently, so the UI part. Okay, good. Here we have it. So what you would do is create an auto-scaling template, or kind of a configuration, in other words. Name it to render VFX nodes. And I would say we have a Blender server here. Okay, let's go ahead and use this template. It's easier, so we can just go away from specifying the node specifics. That will be on some other time. It's just there's too much to cover. Then you can either have, again, a service manage your auto-scaling group, or you can manually just add the types of instances. There's a drop-down. So if you would need an accelerated node or instance, you would choose the G4 group, for instance. These are, with NVIDIA Tensor T4 graphics cards, or with RTX graphics cards. Or you can go for G4A, which is the AMD graphics cards. It's up to your preference. So I will go ahead and choose G4. Let's take G4 extra large. And the weights, I mostly set them as 1. so that they are equal. So another one, G4. Let's take a really big one. 2x large, not too big. So, and this is also equal. So that these two instances would be now in our autoscaling group, which we can just have them kind of rotating, like which one gets chosen first. The instance types, though, what I wanted to talk about is preferably spot instances. Spot instances are up to 90% cheaper. Those prices, the savings, they always fluctuate, so you never know actually how much savings you can get, but rough estimate is that a spot instance is at least 50% cheaper than the on-demand one. And even, like, yeah, I would say on-demand is most expensive, spot instance the least expensive, and the middle range there is the reserved instances. So reserved instance means that you have allocated, you have promised AWS that you will buy this instance for a whole year. So you kind of lock yourself in, but you get a discounted price. So spot instances are the best way to go. One thing to pay attention to with spot instances is the length or duration, how long you use it. Because from AWS, they say you can use the spot instance maximum up to 8 hours. After that, it is removed from your usage, and you have to start again with the new spot instance. But rendering one frame or even a layer almost never can take 8 hours. You can optimize, of course. You can you can have longer than 8 hour renders for a single bit or a single frame, but it's not wise to do so because so many fault points can happen. So you should be safe with using just spot instances most of the time. In the autoscaling group, when it comes to rendering, it's a pretty straightforward process. Considering the compute, you just have to have a pre-configured server template, so to say. So whenever a new server gets created, it is created with the same properties and configurations. So it's best to choose lowest price always. AWS will guarantee that the instance is fully operable, it works, doesn't break down or anything like that. It has the they have the assurance, so to say, for all their customers. And from my history, I believe I've only seen it once when an instance really crashes in a way that it's not my fault, but it's just because of the old hardware. So most of the time, you never have to worry about if you want a super good server, kind of a hardware, or just whatever is lowest with the lowest price at the moment. Because you don't want to waste too much of your monetary resources to rendering because you have iterations and so on. So it's better to just build it up first and then optimize as much as possible. So we go ahead and click. We need some subnets. I'll click all three just to be more available. Next. So in this case, we don't need a load balancer. I know it's a autoscaling group usually is used for other services as well, so you can have a load balancer, but we don't need it. We don't also need a VPC. It will be cloud only for the demonstration part. And let's go on and click next. Scaling, minimum desired capacity will always be 0 because this is what we want, and desired as well 0. Why 0 is because we want to start off with a clean page, basically, so to say. So if after we have configured it, we don't want it to start creating all the resources because they already start accumulating costs. But if we were in a super hurry with a project and we have a tight deadline, I guess it's good to put it to some number if you know you are going to have heavy usage right after you've created this. Or even if you accidentally create it with one due to the auto-scaling rules, because there's no activity, it will scale back to 0. But I always just pay attention to it and make it 0 in the beginning. Everything else is, I would say, a boilerplate. No need to just dive into anything yet. And next is some tags, notifications. We most of the times don't need, because we don't really care about the individual server nodes. All we do care is the logs, which we get anyway, but not the specifics of the life cycle of the instance. If it works, then it works. If it doesn't, then just another one will be created for it instead of it. And now we're going to create this group. And it's created. Currently with 0 instances, maximum is up to 1. You can change these numbers, edit. Let's set it to a bit higher number. Let's say 10, because we have pretty good instances as well. They were, if I'm not mistaken, 16 gigabytes with 8 vCPU, both of them. Another one was with 8 CPU. They should be 33. Yeah, you can see the information here as well. And yeah, you can have more than one of them, so you can render simultaneously multiple jobs. Don't have to wait in a line. Right, so the scaling part is now covered also. So what I would do is go back to the deadline cloud. So let's see if the budgeting issue has resolved. Probably, oh, it has. So now it has recognized that the budget we set is actually set and it is active, so it's good. Sometimes, yeah, you just have to give some time to really finish the configuration. Another important thing in cloud or in hybrid model, I will be, my weight is towards hybrid and cloud in this webinar, is selecting the correct storage. So for storage, you have mostly, like I said in the beginning, 3 options. File system, like regular file system, which is a managed service in AWS. Then object storage, which is S3. You probably have heard about this. And then there is this middle point as well. Yeah, I always want to give 3 options. So the middle one is called FSX. So it's like file system kind of extra. This is, I would say, the most convenient for if you don't really know what you want out of the storage. So let's say you want to connect your local workstation where you work on a project. You have a folder where you keep your files. And this is mounted to your local workstation. But it's actually managed and configured in the AWS cloud. So why this is good, this hybrid approach, is you have the files in both places. On your workstation where you set or you create and draw or model and composite all those necessary things you need to do in post-production. And when it comes to rendering, you already have all of these things, the files, configuration files, assets in cloud. So when the render starts, just starts taking everything from the cloud's location. So you don't need to transfer files or anything. It is very similar to what, it is the same, what AWS, ThinkBox Deadline did, and now AWS Deadline with the self-installed, self-managed version does. You still have a shared folder, and you can manage it wherever. Yeah, a bit about the differences in the price as well when you want to choose a specific storage tier. S3 obviously is the most cheapest. So let's say for maybe a smaller or medium project, you would have 2 terabytes of assets, and storage, amount of storage in S3 to keep is really cheap. So you would basically only, I might be wrong, but $50 a month if you keep that amount of storage in S3. But compared to EFS, which is the elastic file system, this is the most native for mounting a drive. This costs 10 times more. So you really need to see what your requirements are, and also the ease of configuration. What are you more after? Quick and easy configuration, but with a higher bill, or you have more time and you have more expertise, then use S3 and just pay 10 times less. So these are the important things you need to know when thinking or moving or shifting towards cloud or having the hybrid model. Storage is definitely a pretty big bulk in the cloud cost. Let's go in and check at the render nodes. So we have the new render nodes is what I created, but I haven't. I wanted to demonstrate you something that really works. So this is kind of the configuration that you do, and then there are so many resources out there. Of course, after the webinar, I will also share some of the links and documentations that I usually use to set up this framework, a hybrid framework or a hybrid build. So what I do now is I will just show you the local render fleet, which I have set up earlier. You can see it has one worker currently. This worker is a self-hosted, so it's my own PC in the basement, so this how they say, and it's a pretty good one. So right now you can see it was listed, but it's not responding, so something might have happened to it. I know exactly what has happened to it. I turned it off. So in here, yeah, you can see it's gathering the logs, following up. Let's just try to get until the end of it and restart the node because, yep. So, unfortunately, some of you are, unfortunately, most or half the things you need to do is using commands in terminal or PowerShell. So probably if you are used to it, it is natural, okay. Of course, you cannot just out of the blue start submitting these commands. You need to have dependencies installed. You need to have Python for like sure when working with Deadline. And basically what the command is, it's a Python script. I hope you can see it okay. It might be too small, but we can fix this in After Effects. So you specify the farm ID, then you specify the fleet, which is the composition or the group of nodes, and you set run jobs as an agent user. This is something we configured earlier. There are again at least 10 different configurations you can do and how to start this agent, but I will use the one that is proven to work. So carry on and hit enter. You should start seeing a lot of logs now. This is completely normal. This is like a nice picture to me. I like to see changing logs and seeing that it really works. So we give it some time. After some time, this here, it already changed. So it was, it pings, does the health check after every 15 seconds. So you can see it's now idling. It's working. So if we refresh, there are only little details you can see. You can see the worker's logs. And so yeah, you don't miss anything, even if maybe the worker itself shuts down and destroys completely, because these logs, they are stored in CloudWatch. So you can keep those for later debugging. Let's now go to submitting a job, just to see how it all works together. So the job for the demo purposes is a simple, so to say, script. I have taken it out of the demos that I've been doing. So it submits it in Deadline, like in self-managed Deadline. You do this in UI, and what it does internally, it just compiles the config file. So I have the config file here as well in a folder. So these are just sample job bundles. The command to submit a job is again really similar, like we started the worker. So you specify a command and then send out the job with the following properties. The farm ID, you need to take this, you can see it in the background, just copy the value from up here and go back to terminal, and also the queue ID, because queue, remember, you could choose multiple fleets to a queue. So what this now does, it's not a fleet specific job submission, it is a queue specific, and then whatever fleet is assigned to this queue, it will take on the job and starts processing it. So this queue here, it's also the one let me go back, because queues are here. Yeah, it is not the VFX rendering queue which we created right now, just because in demos everything can happen, like we've seen. Thank God we've been fixing them on the fly, but still never know when they really terribly fail. So I have something I have really worked on, and so we have the queue. Yeah, so that brings me back to, so we have to go to another interface. So yeah, the differentiates I show here and like switch between different tabs is, this is the admin view, and this here is the kind of monitoring or client view. So some of the details you can only see and configure in the admin view. Let's go to the queue we were interested in. It was the Windows node. And yeah, you can get the queue ID here. Copy. Also the farm. So if you open this page here when you're logged in, and then you go back to the terminal, you can safely just add the properties and hit submit. So you can see queue name, waiting for the job to be created. Let's give it some time. It's a simple job creation completed successfully. Now, the interesting part, what you can see, let's go to the Windows node queue. You can see a failed, that was from yesterday, and probably the one that I have currently here submitted as well, just right now, will fail. And this is what I wanted to really like demonstrate the failure here, just for you to see some more logs and just see what's missing. Then I will show you how it works on a managed server nodes where you don't need to really do that. But let's dive in. You can see the retries down here. It starts to do them because it always failed. You can see the status of a job never attempted. This is a hint for you that the failure happened 5 out of 5 tries. So I've set the limit. Also, the default limit is 5 times. So yeah, it's a good note, good like interlude. Say you don't have to worry about failing jobs. They won't fail infinitely. They fail for the default level, default amount. It's 5 times. You can increase it, of course, but I don't see the point. If it fails 5 times, it will fail for the 6th time as well. So you then dive into the logs. Let's go ahead and view worker logs. Let's view. Let's go back. So what we are interested in, the specific. Maybe it was down here. Task logs. Yeah, task logs. So this will give us a detailed reason why it failed, and because I was using the locally set up worker, and specifically that to show you that you need to pay attention to details, what dependencies and what environments you have on this worker. So right now it is trying to set up the Python conda environment, and surprise, surprise, this is not installed, so it will never work. So that's the issue you can fall into. But if you have seen it before, you know it, then and you know where to find the logs, because this is the log you will not see in your local worker. This is what will get outputted in this monitoring tool and in CloudWatch. And the never attempted is that the status we saw in the previous page is for the actual job. But yeah, it was never attempted because the initialization failed. Yeah, to fix this, all you need to do is install the missing dependency in the worker. But because I'm not near my worker at the moment, and it would take too much time to really like set it up in this webinar, I just wanted to show you the error. Now, when we, let's say, choose the test deadline queue, this is now service managed. This is fully cloud and fully managed auto-scaling group and all these things. If we try to submit a job to this, then you should start seeing better results. So I have a pre-configured, yeah. So the farm is the same. Well, yeah, you always have 1 or 2 or 3, depends how you want to structurize your rendering farms. But the queue this time is different. I will just go ahead and copy it so you can see the queue matches to not this one. Yeah, didn't find anything, but it will match with the, oh wait. So queue ID. It's not matching. Oh yeah, it is. Yeah. So test deadline queue, the same one we are currently observing in the monitoring tool as well. And thirdly, it is the link ID here. So if we click submit now, you will see the same notifications, same things like with other submission. Okay. Now let's give it some time. It should start appearing in the job monitor here. It's here. Currently ready, not in progress because it's now what starts to happen under the hood is setting up the instance in AWS. Firstly, it will read the rules and then just choose the appropriate instance to use. It will have all the licenses pre-installed, so that's a really neat thing with cloud managed nodes. You don't need to worry about it, you just submit the job. Let's give it some more time because it hasn't yet started running the tasks. It will maybe take like up to 2 minutes to really start processing the job. So you have to account for that. There are ways to mitigate this time and make it really, really short. If you have a clean and really well-optimized base image you launch your instance from, then I've seen the times go down to 40 seconds. So with 40 seconds, you are fully operatable on this node and you can start rendering. Let's see if it has started with any of the processings. Yeah, not yet. So there are 0 workers. They should appear here. But from the previous page, you could see auto-scaling. So this is the scaling group we created. It is showing it's growing. And these are the appropriate instance types. Of course, they are with type spot, which is the cheapest one to use. And we just have to give some more time. You can see other parameters as well. Like what are the limitations of the instances we need to use. So let's see if we have So we have a worker that is already idle. The base or the sample job that I submitted was a really simple one, like I described before, just basically like hello world example, to keep this webinar brief. And here now you see this simple job batch to be successfully tried one time. Didn't need to use up the 5 tries. And now when we go into the task logs, we'll see much better outputs. You see initialization succeeded, it created the conda environment, it then ran the job, which lasted less than a second. So if you would render something, you would see some information here as well. And yeah, it just displayed the workers or the current jobs information. But that was enough for the purpose of the demo. And after that, let's navigate to the correct queue again. It was test deadline queue, under the fleet. So this page again, the test deadline fleet. You can see the scaling status as shrinking, which means it's scaling down. But you can still see the instance down here. And I wouldn't want to just sit here and let you watch. It takes, I measured, 5 to 6 minutes to start really shutting down the service. So this is the amount of time it is configured by the service, AWS service. It's also sometimes good because during the 5-minute window you can start rendering something else or re-render the same frame, project or scene, and you don't have to, you can reuse the same instance then. You don't have to start creating a new one. So it will speed up the start time. But yeah, all the time the worker is idle or idling, you pay for just air. There's really low value in this. And this is what is also the main cost driver when using cloud managed instances, and it might seem scary and unexpected how the cost might grow, and it mostly is just because the instances are there idling, but still pay for the hour or minute. So probably after a bit 5 minutes I would be able to show you something in here that it's gone, but now you've mostly seen how the cloud version of the deadline works. I hope it's been clear. I know I was going over topics and maybe diving into some of the things a lot, but I tried to keep this cloud native approach. So you see that if you set it up here in the cloud, you don't carry the cost yet. You just see the resources, see how your farm is doing, and no costs accumulated at all. The cost will start accumulating only when you see that you have active workers. They're idling, or they are rendering, they are like really processing something, or when you have uploaded a bunch of data assets like terabytes or even hundreds of terabytes of data. If you need that much, then as well your cost will start appearing on your bill. But the ideal use case for a cloud managed deadline farm is it's there whenever you need extra resources or more power to your existing setup. You submit the job using those IDs that we have at least 2 times mentioned to submit your job. While this terminal thing might seem a bit cumbersome and hard to really remember or memorize and configure, there's so many error places that can happen. Just wrong ID is already, you won't be able to render. What I want to say, there are plugins, of course. Deadline is so heavily supported by the industry that most of the most popular tools have direct job submitters. I don't know yet all of them either, but you probably know. So you can keep with this, but just you need to input the correct parameters. And this is how cloud version of Deadline looks like. This is how you can configure it and eventually render. So from now, I would actually want to stop the demo part of the webinar, and I would check with my colleagues at the other side of the screen. If we have any questions you want to really focus that I speak about in the last 5 minutes, or then I'm seeing that currently there is no questions, but I did receive a couple of questions before, so I would be like, these are maybe the most important topics as well. Like the first would be predicting the cost. So predicting the cloud cost is always a topic that we hear, and people want to know like how they create their budgets and how they allocate and quote the customers, how they allocate the money. So there is really no good method. It's just paying attention to your usage. You would, if you use Deadline, even if it's cloud managed or not, you will get the usage statistics. So from these you can use then the calculator that is with the recent years it's been getting really good in AWS. So you can input all those numbers into it and see an estimate cost. And if you think this is a stable kind of a stable usage of your team or a studio, then you can just use this as a prediction quote. So it's there are variations that can happen, but you can get a good estimate. Then also what we've heard previously to this webinar is a question to migrate, because that's always a pain, right? You don't know all the things you need to do in cloud, and maybe some things might be missed. So best way to migrate to cloud if you have a fully local setup is to start with a hybrid, then and then eventually move on to fully cloud. But the hybrid would be kind of what I demonstrated. You set it up in cloud, and you set up all these fleets and queues, and you just make it available. And then whenever team is ready or have gotten the necessary training, you can start, or they can start then sending and submitting jobs to cloud version of the Deadline. And if it works good, then this model can happily be used forever. So hybrid is the best approach I've heard, and what we have done with our team as well. So there are different options. You can just after that move fully to cloud, because you've proven that your hybrid solution works with the scaled mode to cloud. Another interesting one for me definitely is debugging, or like failing jobs in Deadline, especially in cloud. So why the topic is also very burning when we talk with our customers is what happens if a job fails and just endlessly repeats and tries to re-render, because sometimes with some plugins that's the default re-render after failure with the cloud native solutions. But you don't want that, because it can be a really silly error, just a configuration issue. And even if you have a really perfect project and nothing is wrong with the template of the job, it might be something completely else, like memory limit is too low, for instance, and you keep running out of memory, and it just keeps getting into the same thing. So it's an endless loop. But if you have Deadline, it's much easier. With the cloud version of the Deadline, you can get those metrics and information from the dashboards. You can see what is wrong. Do I have to right-size the instance again, or do I have to use a different auto-scaling rule so that we don't kill the instances too quickly? And all those things you can just slightly fine-tune your fleets to be accurate as much as possible. Then there are issues with licenses, like with cloud. If you use the hybrid model and you set up your local render node, completely new one, you might miss installing licenses there. Then from the logs, Deadline will show you, that you have licensing issue. Or even if you use the cloud, like EC2 instance, the cloud instance, also they can have, when you go really custom, you can have issues with missing licenses, and then from the logs you can quickly tell and troubleshoot the issue. And storage, memory, all those things are reasons why jobs might fail in Deadline, but they are not anything scary. So all you need to do is check the logs from time to time, see the health of your cloud farm, and just address those issues in time. So currently checking again but seems like we are wrapped. So thank you for watching. We will definitely be following up with the materials I mentioned, so you can read on and figure out things on your own. And if you're interested in what we do and how we progress in the near time, just pay attention to our LinkedIn page, see our updates, and stay tuned. Thank you.
This is TrainMe, the ultimate render machine. At the heart of Tallinn, amid the noisy startup ecosystem, there is one particular startup that will disrupt the industry of remote computing. Whether you're crafting blockbuster films, epic games, or mind-blowing AI, TrainMe's cloud infrastructure platform will deliver lightning-fast rendering and unbeatable computing power, all with a super-friendly interface. No tech wizardry required at all. Already we have film studios, game developers, and AI geniuses who are riding the TrainMe wave, turning big ideas into reality faster than ever. Get ready, because with TrainMe, the future of remote computing is fun, fast, and right at your fingertips.